So if you had to go back to your 12, 14, 16-year-old self and give yourself some advice through your career, what would you tell yourself through your journey?
I would tell myself to be open to change and to be flexible, but to still, what got me into acoustics was finding this combination of art and science, and that led me, at that time, I was really into performing arts acoustics, and so I thought I had found that thing. So finding combinations of interest and finding a way to put them together is very powerful, but then to also be open to finding how you can apply the same desire for combining things in other directions.
Welcome to the SQL Podcast, filmed in the MD Acoustics anechoic chamber at their testing facility in beautiful Gilbert, Arizona. Each episode, we bring you compelling conversations, practical advice, and illuminating stories from the minds of industry leaders, educators, innovators, and visionaries who are shaping the world one idea at a time. Today, we speak with Derrick Knight, the lead acoustic engineer at Trane Technologies. Derrick specializes in HVAC sound design, 3D acoustical modeling, and the development of national standards. With over 20 years of experience and a Master of Science in Architectural Acoustics, he's a leader in advancing industry standards.
Welcome to the Sound Cave Labs podcast. I'm your host, Mike Dickerson, and today we have with us Samuel Horde, and we have Derrick Knight from Trane Technologies.
Great. Well, thanks for having me. I appreciate it.
We see that your title, right, is Lead Acoustic Engineer at Trane Technologies. Can you talk to us a little bit about what is the Lead Acoustic Engineer at Trane? What does that look like?
So as an acoustic engineer at Trane, we're obviously dealing with HVAC sound, a lot of sound power. And from a tactical perspective, we're trying to facilitate the communication of a very large quantity of sound power data to be accessible to building designers who are selecting the equipment that we manufacture and sell, so that they understand how loud the equipment will be in the configuration that they are purchasing at their operating point they're applying it. And then ideally, they have some in-house expertise or are hiring some expertise to take that sound power data, from which they can, first of all, do an A/B comparison to competitors. But ideally, they can take that data and apply it to design so they can predict a sound pressure level in the very specific building that they're designing.
That's pretty good insight, because I was thinking, so you're taking all this information then in terms of sound data, and you're building out this library so that consultants or mechanical engineers or whoever can use this for predictive analysis when they're doing building design.
That's the ideal. Now, sometimes it, because we, as an industry now, we're talking beyond Trane, managed through the American Heating and Refrigeration Institute, AHRI. As an industry, we've come together to write these sound standards that we all agree on, so that when we publish the data, it's more about the technical differences between the equipment and what it can actually do, rather than getting creative with, well, we measured it this way and they measured it that way, so we can compete clearly and fairly. But then also we go through some extra steps, some extra painful measurements to make sure that the data is reflective of the unit as selected and applied for that design purpose as well.
For those that aren't familiar with the world of HVAC noise, you have a large unit on top of a commercial building, and that makes noise. And then the configuration, like Derrick's been talking about, the ducts, the amount of turns, whether there's lining in the ducts, there are a lot of factors, including the size of the opening into the building where it's pumping the cold air in. So for our viewers that aren't familiar with building design, can you say just a little bit about just sort of the scope of Trane? And I remember one of my first buildings that actually got built, I stepped on the roof and this thing was the size of a semi-truck. I was like, it didn't look this big in the plans.
Yeah, so Trane Technologies spun off as an independent company right before the pandemic. We now position ourselves as a climate company. So we're trying to provide solutions to reduce the energy intensity of the world, basically making our equipment very efficient, provide efficient cooling for our customers. We have goals that we're trying to actually reduce the amount of equivalent carbon in the atmosphere. So just really, really big picture, we're going to market with that as our frame of reference, that we're helping solve the climate problem, because I think, trying to remember what our CEO says on podcast, something like 40% of the building energy comes from the HVAC system. So obviously we play a big role in overall building energy use. So we're trying to go after that and provide solutions, provide smart buildings, and specifically equipment to provide comfort, heating, and cooling. And so to do that, we have a very wide range of products, ranging from really small things you might see in the plenum in your office directly above your head, ranging to the stuff on the rooftop that's so big it had to be split across multiple semis to be driven to your site and installed and assembled there. Or maybe in your mechanical room, you've got a giant water-cooled chiller. Those are actually made here in La Crosse, Wisconsin.
Always, I would feel like, we get called in sometimes and it's like, hey, we got this noise and it's HVAC related. And you're just like, okay, we got to go look at all the HVAC. And it's like, sometimes it's like untangling spaghetti for us. And so no, it's awesome that you guys are going out there and you have all that stuff. I guess one of the questions I really had for you though is, and we're going to dive into it. You can see I have a fan here, which is not part of your systems at all. Do you have any input on design, or is it mostly measurement after your mechanical teams come in and come up with a design, you measure it? Or they design, prototype, you test, report back? Can you kind of shine a light on that?
I do get involved in the design process, and how deeply I get involved and how much influence I have over what happens depends on the scope of the project. So from a very simple project perspective, I might not have much say in which particular fan or compressors we're buying. There's other considerations driving that decision. Marketing decisions are being made. But I'm involved in the project planning, because to do all of those sound measurements to make that catalog of data, it's actually it's a database that interfaces with our selection software, but you can think of it like a giant catalog, I guess. To do that amount of measurements takes a great deal of planning. So sometimes the decisions they're making about product complexity means sound rate complexity. And so we're trying to keep track of that so we can plan our resources properly. So at bare minimum, I'm involved in the design process to keep that variable in mind. Then if there is an acoustic goal to go after something quieter, then my role gets shifted up in priority. May help evaluate vendors if it's about picking a quieter fan, and then doing some validation tests early on to show that like our vendor sound data led us in the right direction, because it's going to be different in unit. Or in some cases, then it's about designing something to be specifically quiet, and then having influence over not just a part, but the entire configuration of the unit. Those are pretty rare. More common is the first two, where it's either just making sure we can get the sound rate done in a timely fashion, or helping select parts and then making predictions of how we think the test will turn out in the end, so we don't get too far down the road before we find out the bad news.
It's funny because we get called up. We do a lot of prototyping, product design. We do a lot of tweaks. We get called in quite often to do that. And I always feel like when we get called in, it's like I'm like thinking, and we interact with lots of engineering teams in big companies, and you kind of, when you get called in and all eyes are on you, I'm kind of like, where's the acoustician or the aeroacoustics person in the company, and how come they're not one of the voices at the forefront? And I always feel like acoustics is like the last to be considered in any, whether it's a building, but also in product design. One of the things I hope from all this podcast is that companies in general listen to the acoustical engineers a little bit more, because noise pollution is a real thing. And it definitely impacts everybody across the world. And so like our phones ring off the hook, and I know it's not just us, but a lot of consultants and engineering companies, their phones ring off the hook because there's a lot of noise. And HVAC is part of that. And so if there's thought process, and I'm sure there is, but if you could come in with the acoustics mindset as one of the top priorities, I don't know if it's like the top 5 or top 10, then it kind of helps drive that. And that's when we come in and step in. Honestly, I kind of come in and I'm like, you know what? You're here. You're bringing us in. We're the top priority. That's kind of how I always pitch it. And, not every project's like that. Not everybody agrees with us. Trane is notorious for obviously chilling. I mean, here in Arizona, we've got data centers up the wazoo. We've worked on a lot of data centers, us personally. And, you're cooling electronics with these massive chillers. Does Trane I got to think you spend a lot of time designing and developing these water-cooled chillers versus air-cooled chillers. Can you talk to us a little bit about the efforts being made there for energy efficiency, acoustics?
We're seeing the incredible demand for data centers, just like everyone else is. Data centers is really, from my point of view, stressing the productive capacity of the world, both in terms of energy and in terms of being able to provide the materials and the construction and the proper sites for all of it. So that's a fast-growing market for us. Well, I'm not deeply involved in the business side of it, but I do hear obviously a lot about it. There's a data center project going on right now that I'm involved in that I can't talk about. But yeah, we're to my understanding, we're selling a lot of water-cooled chillers and air-cooled chillers into the data center market. They have different advantages. Obviously, we're trying to keep up with the innovation. Trane is like over 100 years old. We have been doing human comfort design for a really long time. And then along comes data centers, and they need massive amounts of cooling, but they want to maintain like 90 or 95 F instead of 70 in a occupied building. So the job of the chiller is very, very different when you're trying to maintain those different temperatures and the amount of heat that you're trying to expel. Maybe it sounds like an easier job, like, well, 70 is cooler than 95. Shouldn't that be easier? But the quantity of energy you're trying to dissipate is massive, as I'm sure you've experienced. So it is challenging what our traditional designs have been, and I know we've been iterating new things much faster than we had in the past. And I guess luckily I don't know the details of that, so I can't ruin anything. But I'm unable to provide any.
No, it's good.
Technical insight as to what kinds of things we are doing.
No, that's okay. That's okay. And no worries. I was just thinking more of because we've worked on. I'll tell you, we worked on a project, and we can disclose a little bit about it, but you've had 144 Trane chiller units, in one area. That's massive when you factor that in. And it's a hot topic. It's going to be a hot topic, and it's a topic that will be discussed, obviously, more and more for the future generations, because, data centers are here. They're not going away. They're going to be even bigger and bigger. So these are real problems that people are concerned about. And energy, the first thing is energy. And then beyond that, obviously noise and the other things. But they're all necessary, right? Like if we're going to live in a world of technology, and where we have technology at our fingertips, and with the AI and everything that's coming down the pipeline even more, it's here to stay. So we all have to kind of figure out how to work together and build these buildings to be cleaner and quieter and everything else with that. So our experience has been, it was awesome to work with Trane. Our experience was awesome that we were able to quiet a significant amount of the noise coming off these systems, and a lot of advancements been made in this space. So we just appreciate the fact that there is data out there and that advancements have taken place, and you're part of that. Speaking of AI, your role as the lead acoustic engineer at Trane, how much do you use AI for your day-to-day?
Not really at all at this point. We have rolled out an AI assistant that's within the corporate system, and I've played around with it and started to understand what a large language model actually does. And I haven't found the right application for it. I can imagine lots of ways in which it could supercharge many engineers, and I can imagine ways it could help me in its current state as a language model that's trying to give you an answer that's holding up its end of a conversation. That's very different from what an engineer needs, or could could benefit from in terms of having true true statements that can be backed up through citation, so that when a business leader asks me for my expert opinion on the acoustics of something, if I could go to an AI engine that I could trust, that if I had questions, I could find the citations and go read the source materials myself, that would be useful. And then, beyond that, going beyond language, being able to more naturally interact with large amounts of data that are human labeled. We have systems in place to try to make our tests understandable from one engineer to the next, but we're also human, and we have invented thousands and thousands of metadata fields, not all of which are always filled in, not all of which are always filled in the same way. So the idea of an AI sort of sifting through all of our data, I'm sure that will happen. I hope sooner than I think. But right now, there's just the human challenges of, there's massive amounts of data, but is it organized in a way that that AI can actually speed up versus an engineer just having to sift through it and look at everything and do the hard work, diligent work of looking at the metadata and make sure you know what that piece of data actually is from, what it really represents in the real world.
We run into this all the time, where we were on a meeting just this week where something was implemented in the field that differed from the laboratory test reports that were available, and kind of sort of sifting through and dissecting, like, okay, but here are the differences. This is why it's different than maybe you had expected it to be. So it sounds like you're running into a similar type of thing with your testing and data needs, where a predictive text model, it can give you some convincing sounding answers, but how well does that match up to the reality of the situation? And how well does that balance with your engineering judgment as to what could actually be going on there?
Yeah, and if I could selfishly request an AI tool, would just be able to read the standard that I already know, but like there's a detail in it, like, oh, what was that detail in the standard? Ask the AI or assistant to go get that for me would be helpful.
That would be amazing.
Had success using it that way.
For those that haven't been through like an ASTM or an ISO standard, they're incredibly dense and dry and detailed, and going back and trying to trace down, I need to know exactly what I need to do with this piece of data, how I need to handle it.
Where's the innovation in terms of acoustics? I still ask myself this every day, and my team hears me say this all the time, right?
Yeah.
All day. There's so much still yet to be invented in acoustics that can be done. That's not just loudspeakers. No offense to loudspeakers. We have like lots of companies coming on. But there are things that could be done that could improve people's lives. And this is one place where, investment and efforts need to be made and can improve upon it. And, that's one of the things, that's the point of the podcast, right? Is to, part of it is to tell ourselves and to kind of get out there in the industry and just show that, hey, there's a whole industry of people who do measure sound, who do design products, and are changing the world for the better. So I kind of laugh about the podcast because I'm like, I don't know if this is a success or a failure, but I just feel like, it is what it is, and it's good. It's fun. It's been something that's been really rewarding personally.
So on that topic of risk and reward, Derrick, what are some career risks that you've made in your career, and did they pay off, or are there things you would have done differently?
Most of the career changes I made along the way had obviously some element of risk. I grew up in a small town in the Midwest and went to college as a music major and left with a degree in physics and got into acoustics. And in my college education, I was searching, way back then we actually had the internet. It was really early days, but we did have the internet back then. Searching for opportunities in acoustics, and stumbled across this thing called concert hall acoustics. And here I am in the Midwest, where there's not a lot of concert halls being built, but actually one was being commissioned. One day I noticed the newspaper had an article on someone who, those of you in the consulting world will know, Kierkegaard and Associates. They had an office in Colorado. They were commissioning the pavilion in Sioux Falls, South Dakota. I saw this article, and I was like, and by this point, I'd actually stumbled across acoustics in concert halls a little bit. But I really want to talk to this person, and I don't recall how I managed to get this consultant's phone number. I was able to talk to him while he was in his hotel room, still in Sioux Falls, commissioning that performing arts space. And he generously gave me about an hour of his time to talk about the business and acoustics. And then he hooked me up with someone else in their office, a younger person who was just coming out of grad school. And I found Concert Hall Research Group was doing their first summer institute in Pangolin, Massachusetts. So I applied for that, having no formal education in acoustics at that point. I was able to got a grant to go attend that, and got me into introduced to several of the important consulting firms of the time. And Chris Jaffe had recently started the Architectural Acoustics program at Rensselaer Polytechnic Institute. I saw that as a good school for kind of where I was aimed at. And so I went for that, and graduated from South Dakota, got married, took my wife and I out to upstate New York. My wife was a teacher, but she couldn't teach in New York, so she took a nanny job. And so she was my support person while I was still in school then, with our luxurious nanny salary. And took the risk to move out. Like, you're two young kids, just married, own almost nothing. So I did grad school there, and then was fortunate enough to get a job with Chris Jaffe's firm, Jaffe Holden Acoustics, as my first job. And so I was there. I was doing that thing that I found was the combination of the art and the science and the music, acoustics, and all that jazz. And then, the real world intervenes and kind of throws your plans for a loop. 9/11 happened shortly after I'd started at Jaffe. And to their credit, they tried to keep a hold of everyone for quite some time after that. But the economy had a lot of uncertainty, and all these projects they had lined up were one by one going on hold. And they eventually had to let some of us new consultants go. So I got to experience my first episode of involuntary unemployment. So now what? So then my wife and I had thought we imagined someday we would get back to the Midwest in some way. I didn't really understand how, because Concert Hall Acoustics is pretty coastal in terms, or at least it was then, in terms of the firms and their locations. Or Chicago was your option, I guess. But at that point, we decided, well, maybe now is the time to try to get back to the Midwest. Not a lot of people were hiring. So I took a job at Orfield Laboratories and took a risk going to a place I'd never been, a firm I didn't know a whole lot about, and did that for a couple of years, where I got to be involved in my first acoustics laboratory. So an anechoic chamber, reverberation chamber, and then I was doing most of the architectural acoustic consulting, but was helping in the lab as the lab quality manager. That was a pretty great experience there. And then I decided it was time for me to move on from that opportunity, and I didn't know how I was going to transition out of it. And along comes this email from someone I went to college with. He didn't even know I was in Minneapolis at that point. He thought I was in Texas. Can't explain why he thought I was in Texas. But he emails me and says, "Hey, I'm at this school. We're looking for someone to teach acoustics and probably some math too." And so I was like, "Well, I'm actually here in Minneapolis. And I'm ready to move on." So long story short, I started teaching. So I took a job at a 2-year college called the Institute of Production and Recording in Minneapolis, Minnesota. They're no longer open. They closed, I think, officially last summer. But at the time, they were offering 2-year degrees in audio production, audio recording, music business, and some other media-related 2-year degrees. You needed someone to teach college algebra, because you have to have a credit in college algebra to get an associate's degree. Needed a pre-algebra class for some of the students, and then they had an elective in acoustics. So I got to teach a science. I taught on the Science of Sound by Thomas Rossing.
Huh.
So that was a big risk, a big transition from doing a consulting to teaching. But I also started then my own consulting firm on the side, working for architecture firms. Actually, had a non-compete, so I was working for architects in Sioux Falls, South Dakota. So I was living in Minneapolis, teaching in Minneapolis, but trying to build a consulting client base in Sioux Falls, South Dakota along the way. So did that for a while. And then the teaching gig kind of came to a close when they decided gen ed faculty they didn't want them to be full-time anymore, which meant I lost my health insurance. So I decided it was time to go find something else. Was able to find a part-time consulting engineering role at 3M, a contract engineering role at 3M in the automotive acoustics division. So at that time, then I was doing 20 hours a week in the automotive acoustics laboratory at 3M. I also then managed to get a consulting contract with a different division that was doing stuff that never came to market, but I probably can't talk about. And then still consulting for architecture firms. And so I was juggling a lot of things. Did that for a couple of years. Life was getting chaotic, and decided it was maybe time to grow up and be a real boy and simplify my life a bit. So I started looking for jobs, and this opportunity at Trane came across my way, and I applied for it. And 10 years later, I'm still settled here, so I feel pretty good about how I got here. But yeah, a lot of different changes along the way. Some of the changes I decided it was time for myself to move. Other changes, real world intervenes and makes decisions for you, and then you got to go figure it out.
You're vice chair of S12. You're a chair of sound and vibration standards, right, of AHRI. And, you're also a member of the ASHRAE TC 2.6, I think it is, or participant of that. You got all these like standards, and you were talking about earlier, hey, I'm part of these organizations because you want to help standardize measurement processes probably. And then on top of that, and so correct me if I'm wrong, but it's also mentorship, maybe for some students that are involved with different universities. Talk to me a little bit about what's the drive there to be part of these committees and these standards.
So standards, of course, have always been important in science and in especially engineering. So we all understand when I look at your test report and you say you did it to this standard, if I'm not familiar with it, I can go get that standard and read all the details of how you acquired that data and understand all of the processes that went into it and the assumptions that are baked into the particular test setup that you used. So that's really important to be able to understand when you're comparing data between manufacturers. It also facilitates cooperation across competitors, that we cooperate on these standards so that we can choose to compete in where we think it matters and cooperate for clarity and to make it for everyone's life a little bit easier. The standards world there's quite a bit of gray hair in it. And so when I came to Trane, there was plenty of opportunities to step in and take over some of the committees. So I took advantage of that. For a company like Trane, standards are obviously really important. I've started things. Standards help us monetize our trust in some way, where if when we publish our data to a standard, occasionally standards are attached to like a certification program where you do have an independent organization auditing your stuff. So they'll come to your warehouse and they'll say, we're going to pick that one, and that one, take it to our independent laboratory. We're going to measure it according to the standard, and we're going to check your catalog data. And we participate in some of those certification programs, but most of the data we publish aren't part of certification programs. And so what you're really doing is in looking at the standard data is you're understanding what we're giving to you and trusting that we went through that hard process of doing the testing in accordance with the standard. So you understand that it's quality data. You understand how much uncertainty there is in that result and what it actually means as you try to apply it to your building design. So there's lots of ways standards can be used, lots of ways that they're important. But like to me right now, where I'm at Trane, that's kind of where I'm focused on trying to make sure that to facilitate some transparency and clarity about what our data is, where it came from. And the reason Trane believes in it so much is it really helps us in the market for people to understand the technical aspects of our product, but allows then customers to focus that on the more important things where we can maybe do the same job at a quiet level, but more efficient or some combination thereof.
So you've been there about 10 years. How much, like if you could say a percent different the standard is now as opposed to when you started sitting on those committees, do they change very much or very fast, or are they pretty stable?
They're pretty stable. So if standards are very complicated. There's lots of standards development organizations. So AHRI, some of the standards we publish are, our standard process follows ANSI, which just means there's a bunch of rules that we have to adhere to so that we can publish in ANSI AHRI standard. Some of the standards aren't ANSI co-published, but we follow the same process anyway. So the process is unfortunately a little cumbersome, which does make it slow to change. So I'd say most of the standards they're definitely getting updated. We go through them with a fine-tooth comb. Sometimes it's like, wow, I can't believe no one noticed that mistake before. But at the same time, smart engineers tend to be using these standards, and they kind of get self-corrected, and they forget to tell the developers, like, oh, you made this mistake. But yeah, they're slowly changing. Sometimes, I'd say pretty rarely for a mistake. More often, the change in technology, or someone comes with a question, like a consultant reads the standard and they don't quite get why we're saying something or doing something the way we are. So we might update the wording just to be more clear, more transparent about it.
So if you had to go back to your 12, 14, 16-year-old self and give yourself some advice through your career, what would you tell yourself through your journey? What from based on your experience?
Yeah, I think I would tell myself as I went through my career, we were talking about all the changes. I would tell myself to be open to change and to be flexible, but to still, what got me into acoustics was finding this combination of art and science, and that led me at that time. I was really into performing arts acoustics, and so I thought I had found that thing. So finding combinations of interest and finding a way to put them together is very powerful, but then to also be open to finding how you can apply this same desire for combining things in other directions. So yeah, mostly just to be open to change and be flexible and be ready for life to make plans for you.
You were interested in music and acoustics. What instrument did you play? You almost majored in music.
I played percussion.
Oh, we love it.
Yep.
So basically you're wearing, hey, we have some show and tell. Because I was curious to know also in the lab what you're wearing. Are you wearing double ear protection? Are you just wearing over ears? Are you wearing earplugs? What you doing there?
Mostly I'll wear the cheap, foam earplugs. Don't need them too often. Our stuff's so quiet. We don't really.
No, there you go. Boom. I love it. Yeah, you got it. That's the way to do it. I remember we were up on the rooftop and we'd opened up like a Trane unit as a huge air handler. And we couldn't close the door because the air pressure was so strong. We made a mistake. we didn't get swapped off our feet, but this thing was full bore. Yeah, you should have told. You should have told us. No. For those who think that his stuff is actually quiet, he was making a joke, and it was hilarious.
No, it is. Listen, it is quiet, relatively quiet. It's all relative. So we hear that coming through. So we're good.
Yeah, we're doing some lab modifications. That's not actually Trane equipment. That's right.
Oh, sure.
Hey, that's good. Well, we appreciate your time here, Derrick. We appreciate everything, you spending a little bit of time with us. And we hope that this was informative to our audience and guests. If you haven't had a chance to check out who Trane Technologies is, we'll put a link in there, right? For sure, go check them out. Derrick, is there anything else you want to say in terms of, anything else you want to throw out there? People want to go check out a little bit more about Derrick, or if they want to go check out a little bit more, ASA, I mean, this is your shot.
Oh, sorry. I didn't come prepared to do the whole plug kind of thing. But yeah, I would encourage, especially students, to check out the Acoustical Society of America. There's a lot of scholarship opportunities to go attend conferences. It's a great place to explore the field. Acoustics is very specialized, but very super diverse in terms of how you can apply bioacoustics to hearing and health, to industry and speakers and headphones and all kinds of things. So I encourage you to check out the Acoustical Society of America if you're trying to figure out where you want to go with your career. Attend a conference. People there are very generous with their time. They want to help you find your way, and just don't be afraid to put yourself out there. I've been fortunate to have some mentors. Some mentors gave me 1 hour on a phone call one day. Others spent years helping me out. If you ask and you're open and you're curious, you can go a long ways just by finding someone who's happy to donate their time to help you along the way. So put yourself out there.
I love it. That's good advice. So put yourself out there. I think a lot of the people in the acoustics and engineering, sometimes they struggle with just that communication. So learning how to tell your story, learning how to ask is a big deal. So that's great advice and great. Thank you, Derrick, for coming on today. And with that, we'll end our podcast.
All right. Thanks for having me.
Thank you.